Hey guys, we are going to be talking today about domain and range and two other things that are relation and function. So let's go ahead and get our notebooks out and get going. All right, go ahead and title this relation, function, domain, and range. These are our four vocabulary today, and they're going to be super important that we get them down just to help our mind to start the process of getting this into long-term memory. First of all, a relation is a pair of inputs and outputs. So everything that pairs an input with an output is called a relation. Okay, everything. You put something in and something comes out, relation. Anything that can be written as an ordered pair of x, y is a relation. Now, a function is a specific type of relation. A function is a relation that pairs inputs with only one output. Inputs cannot go to more than one output is the whole point of this. Okay, domain is a set of all possible inputs, x values, and range is all the set of all possible output values, y values. Sometimes you'll hear this as a function machine is what we're going to be learning about. Okay, big picture, relation versus function. A function pairs every input, one output, input, one output, input, one output, input, one output, and this is called our vertical line test. Our vertical line if we're given a graph, if we can take a vertical line and it only hits the graph once, it's a function. Okay, if we take it and it hits the graph more than once, it is not a function. If we're given a mapping diagram or a table, if 1 only goes to one number, and 2 only goes to one number, and 3 only goes to one number, or 4 only goes to one number, it's a function. It is okay for 1 to go to 1 and 2 to also go to 1 as long as 1 and 2 input values, x values, only go to one number. Okay? If 1 goes to two numbers, 1 and 2, this is not a function. This is okay. This is a not function. All right, let's go ahead and start with our examples. Find the domain and range of the function. So first we're going to write down examples for domain and range. And we talked about this yesterday. Okay, so first of all, domain always goes with x, range always goes with y of the graph. So the domain is a set of all the numbers. Domain, -3, -1, -3, -1, 1, 3. Range is a set of all y values. So these ones go to -3, these ones go to -3, so the set only goes to -3. Number 2, the domain. Oops, that's range. Domain, -2, -1, 0, don't forget about that one, 1, 2. So we're squishing all of these points onto the x-axis for domain. We're squishing them on onto there. Okay, for range, now we're going to squish all of these points right here onto the y-axis. So if we squish them onto the y for the range, this is what we would get. Range is 0, the set 0, 2, and 4. All right, the function, which means that function, remember function means one input goes to one output. So this is saying if you put something in, you're only going to get one number out. Gives the number y of avocados you have left after making x batches of guacamole. Identify the independent and dependent variable. Independent variable is x, dependent variable is y, independent variable is the domain, and the dependent variable is the range. So this is what we've just learned. All of this all together, lots of ways of saying almost the same thing. So identify the independent variable. Given the number of y avocados, dependent is avocados, and X batches of guacamole. Batches of guac. Okay, because it said it in our sentence that way. The domain is 0, 1, 2, 3, and what is the range? If we plug in 0, negative 4 times 0 is 0, plus 14 is 14, so the range goes 14, comma. If we plug in 1 batch of guacamole, negative 4 times 1 is negative 4, plus 14 is 10. 2, plug in 2. Negative 4 times 2 is negative 8, plus 14 is 6. And 3, we're going to plug 3 in. And negative 4 times 3 is 12, and we'll have 2. Our range is y values, and our domain is x values. We don't really like this way. We really like it written like this, by the way. 6, 10, 14. But it's okay for now. Okay, let's go ahead and look at examples for function and relation. So different set of examples for function and relation. Determine whether this is a function. If the relation, everything's a relation, but not everything's a function. Okay, so 1 goes to negative 7, but 1 also goes to negative 5. So 1 goes to negative 7 and also goes to negative 5. 2 goes to negative 4. 3 goes to negative 1. And 4 goes to negative 1. Since 1 goes to 2 numbers, this is not a function. Not a function. Every input only has 1 output. 1 had 2 outputs, so this is why it's not a function. So number 2, I'm going to draw our mapping diagram so we can see this better. Negative 3 goes to 1. 0 goes to 0. 3 goes to 1. 6 goes to 4. And 9 goes to 9. Everything, every input, here's all of our inputs, only went to 1 output, and so this is a function. 3. 6 goes to 5, 7 goes to 1, and 8 goes to negative 3. None of these went to 2 different problems. None of the inputs went to 2 numbers, so this is a function. All right. 4 went to 1.5. Negative 2 showed up twice. Not a function. Not a function. Because negative 2 shows up twice. The input of negative 2 shows up twice, going to 2 different numbers. Makes it not a function. All right. Number 5. This is called a mapping diagram. 1.4 went to 0 and 1, and 1.6 went to 1 and 2. Not a function. They went to 2 different things. 10 went to one thing, 1 went to one thing, 5 went to one thing, and 13 went to one thing. This is a function. Now, don't make that little mistake thinking, but they can't all go to the same thing. This is okay. Having them show up twice here in the input value is not okay, but this is okay. All right, I think I have a couple more examples for function versus relation just to help us remember. Okay, when we're given a graph, the easiest thing is to do a vertical line. So I'm going to draw a vertical line. Does it hit more than 1? Nope, so this is a function. We're going to draw a vertical line for number 8. Am I hitting it in more than one spot? Yes, so this is not a function. All right, problem number 9. Let X represent the number of each month, input month, okay. Let Y represent the days in the month. This is days in the month, okay. Do not consider a leap year. Complete the table. So 1 is January, and how many days are in January? Let me go ahead and look that up because I don't have it memorized. Hopefully you guys do. Oops, hit clock. January has 31 days in it. February has 28 days in it. March has 31 days in it. April has 30 days in it. May has 31 days in it. June has 30 days in it. July has 31. August has 31. September has 30. October has 31. November has 30. And December has 31. 4, 5, 6, 7, 8, 9, 10. All right, does this represent a function? Did 1 go to more than one number? No. Did 2 go to more than one number? No. Did 3 go to more than one number? No. 4, 5, 6, 7. This is a function. Yes, it is a function because every input every month had days outputted. January doesn't have, because we didn't consider a leap year, okay? January didn't have 2 separate days of the month, okay? All right, let's go ahead and go to our on your own problems. Find the domain and range of numbers 1 and number 2. Pause the video and come back when you're ready to check your answers. Thank you for pausing your video. For number 1, here's your domain, here's your range. You do traditionally see these written as a set of numbers right like this. It has those little set. But here's our set of numbers going from in increasing order. All right, go ahead and answer that essential question and your checkpoint is ready to go. I hope you guys are having a good day.